Yeah, so I'm Shaun Walker. I'm excited to be speaking at this CodeCamp event today. I'm going to be speaking on building dynamic applications with Blazor. So I'm Shaun Walker. I'm a technical director and enterprise guild lead at Cognizant Softvision, which is one of the sponsors of this event. My claim to fame is that I was the original creator of a very popular web application framework called DotNetNuke. That project started way back in 2003, and I spent many years developing that solution. I became a Microsoft MVP at one point. I was an MVP for, I think, almost 12 years. I'm not an MVP at the moment. Actually would love to become an MVP again, but I'm contributing a lot to the .NET ecosystem regardless. An ASPInsider. I'm also chair of the .NET Foundation Project Committee. That's a committee that is responsible for reviewing new project applications, projects that are open source in the .NET ecosystem that would like to become members of the .NET Foundation. We actually have a whole group of folks on the committee that are focused on those activities. And more recently, I created another open source project called Octane, and I'm going to be talking a little bit about that today. I guess another little bit of information, I'm a Canadian, but I'm currently living in Florida in the United States, enjoying the sunshine. So don't want to make anyone jealous, but definitely love being in Florida. So I guess getting into this presentation about dynamic applications, first of all, I need to explain the opposite. So what I mean by what the opposite would be a static application. A static application would be an application that requires a full software development lifecycle in order to enable new functionality. And if you think about the applications that you're building today, probably the vast majority of them would fall into this category, meaning like if you want to add new functionality to the application, you would actually have to open up the source code, you'd have to make modifications, probably do a build, do a full deployment. And this would be even for very trivial modifications to the application. You'd have to go through that full software development lifecycle in order to enable that functionality into a runtime environment. So when you're building static applications, I mean, typically you would start with, the new project wizard within Visual Studio. And that's what I'm not going to be talking about today. I'm going to be talking about dynamic applications. So dynamic applications are a completely different breed of application. Some people call them plug-in applications. Some people call them modular applications. For the sake of this presentation, I'm going to be calling them dynamic applications. And basically, these are applications that can be extended very easily at runtime to enable new functionality. Dynamic applications have a number of benefits that come along with them. Benefits such as extensibility, because they are very loosely coupled in their architecture. It allows you to add new features. It allows your development teams to work on the application in parallel without conflicting with one another. Typically, they have a set of conventions that you would follow in order to sort of provide more a predictable and consistent outcome to your software development experience. They tend to follow encapsulation principles, meaning you would break down your application into smaller pieces, and you'd encapsulate the functionality into those smaller pieces, and then those pieces would be combined together at runtime. And then there's also the benefit of deployment, where the features can be deployed independently from one another instead of doing a massive sort of monolithic deployment. So there's a lot of great benefits of dynamic applications. So with that, I'm going to just move this slightly. So dynamic applications are difficult to create. So with all the benefits that they provide, they're still very difficult to create. So developers who build these types of applications typically rely on web application frameworks in order to accomplish their goals. One thing that's become quite popular in recent years is this concept of batteries included frameworks. So basically frameworks that provide you with all of the basic components that you need as a developer to get up and running. And so a lot of frameworks that developers rely on today provide you with a great set of building blocks that you can get started with. However, it's not always obvious about how you should assemble those building blocks to build a really robust enterprise web application. And so batteries included frameworks go that extra distance to provide a lot more guidance. A question that often comes up is a content management system a dynamic web application? And in a sense, it is, but I believe, this is my own personal opinion, content management systems tend to focus on content-oriented scenarios, things like content versioning, content localization, workflow. I mean, there's a whole set of content-related activities that they focus on. Typically, a content management system is built on a dynamic web application framework underneath, but on its own, a CMS would not be a web application. I mean, you could build a CMS on top of a dynamic web application, but it's not one and the same. In the .NET ecosystem, of course, we've had access to a number of frameworks, right? We have the .NET framework, we have .NET Core, and in fact, I mean, these frameworks are the primary drivers of platform adoption. And so what I'm going to be talking about a bit more today is frameworks that are built on top of these frameworks, which provide a more optimized developer experience for developers who want to build advanced web applications and, you know, don't want to have to try and figure out how to assemble all of the pieces that they offer on their own. Blazor is an exciting new technology from Microsoft, released a couple of years ago. It's basically a single page application framework that allows developers to build full stack web applications using C# and .NET Core. So this is the full stack aspect of this is very important in the sense that most single page applications that are being built nowadays are being built with, you know, a back end, which could be in .NET Core or, you know, perhaps some other technology, and a front end that's built on a JavaScript based framework, such as React, Angular, Vue, or others. But that experience means that you basically have to understand two very different sets of technology in order to build a web application. And what Blazor provides is a consistent set of technology, both on the front end and the back end, that you can utilize to build a single page application. Blazor is very versatile. So the very cool thing about Blazor is it shares one consistent development model built around the notion of Razor components. But then those Razor components can be hosted in a variety of different ways depending on what your application requires. So two of the supported models that exist today are Blazor Server and Blazor WebAssembly. Razor components, I mean, if you visualize what a Razor component is, it's essentially a bit of HTML markup that is a partial, you know, makes up part of your user interface. A component is a file, a .razor file, and components have capabilities, all of the major capabilities that you would expect that a component requires, such as routing, the ability to pass parameters to a component. It's got event binding and property binding to sort of give you the full life cycle of passing data back and forth from your backend code to your user interface. And it's got some life cycle events that you have to become familiar with, which basically help you in understanding the different phases that the component rendering lifecycle goes through. So very interesting new technology. I believe that, I mean, the component model is actually pretty common in most front-end frameworks nowadays. So if you look at frameworks like Angular, React, of course, they have their own component model as well. And they possess all of these basic capabilities that Razor provides you, or Razor components provides you as well. In the Blazor server model, the actual Blazor application itself is actually running on the server, and the interactions with the application in the browser are happening over SignalR. And so this is one particular hosting model that you can use to deploy a Blazor application. It's a model that is, you know, quite familiar to a lot of .NET developers because it utilizes all of the standard tooling and debugging support that you've come to expect if you've been building, you know, MVC applications, or, I mean, even older, perhaps web forms applications. But the basic model is very familiar and very comfortable for .NET developers to become accustomed with. There's also a newer model, and this is sort of the genesis of Blazor actually came about because of this new model. And it takes advantage of a new, basically, internet standard called WebAssembly. WebAssembly is basically the ability to have almost like binary code that you can run in the browser. And it enables you to write very interactive applications. WebAssembly is supported in all of the major browsers nowadays. And the way that a Blazor WebAssembly application works is basically you deploy your application to the server, but when a browser connects to your server-based web application, it actually downloads the binaries of your application to the browser. And then from that point on, it's actually running natively within the browser itself. So this is a very powerful capability, and it provides a lot of benefits in terms of especially performance, because it doesn't have to download a lot of JavaScript, parse that JavaScript, compile it, and run and get it into a form that it can interpret. Basically, your application is pre-compiled into binary form, and the browser is able to understand that binary form and provides a very performant application experience. Microsoft has recognized sort of the versatility again of the Blazor component model. And so initially they released support for Blazor Server and followed that up with Blazor WebAssembly. It is also possible to build progressive web applications using Blazor today. Basically, the WebAssembly template that is shipped by Microsoft enables progressive web application functionality if you want to enable that in your application. In subsequent versions of .NET, like .NET 6, which will be coming later this year, there is attempts to also make Blazor run in other environments, such as desktop environment, native mobile as well. So this will open up some additional hosting models that you can render your Blazor components into. So, I mean, then you'll be able to cover anywhere from, web scenarios all the way to desktop and mobile in a native manner, which is a super powerful and versatile technology. And this is, we've been waiting a long time to have a technology that would run sort of one code base that can run natively across all of these different platforms for some time. So this is, I'm really looking forward to being able to utilize Blazor in both the hybrid and native context. And with that, I'm going to talk a bit about the open source application framework, which I've been working on in recent years. So this is a modular application framework that was built natively on Blazor. And I started building it on Blazor when Blazor was still in a preview state, but it's advanced quite significantly since that time. The Octane framework is a batteries included framework, and it runs natively on .NET Core and Blazor. It's designed for creating modern web applications, which hopefully allow you to write less code in the process. It gives you a robust set of building blocks and services that you could take advantage of out of the box. These would be things that are not provided natively in Blazor itself or .NET Core. It's licensed under an open source license, an MIT license, and it's actually the project is a member of the .NET Foundation. The project itself is basically one code base, and it runs on both Blazor Server and Blazor WebAssembly without any modifications. And I like to refer to it as rocket fuel for Blazor. Some of the capabilities that the Octane framework provides you, one of the big ones would be multi-tenancy. And I know Iris just did a complete presentation on multi-tenancy. So the Octane framework provides multi-tenant capabilities out of the box. It actually provides both the ability to have shared multi-tenancy and isolated multi-tenancy capabilities. So if you want to have your data sort of commingled in a shared database, which actually is a preferred model that a lot of folks like, it supports that capability, but it also supports an isolated model where you have like what Iris was describing, which is a master database where it contains sort of the mapping to the various tenant databases. So it supports both of those models. It also takes advantage of custom features such as dynamic routing, which I'm going to talk about. It has a portal user interface framework, which is basically a compositing framework which pulls your user interface together in a dynamic way. It utilizes a modular architecture, which is really the fundamental aspect of the whole framework, is breaking down your application into more modular pieces. It's got a granular permissions model for advanced security, for securing your web applications, providing capabilities over and above what is available in .NET Core. It's got the ability to add customizable themes. It's got an admin user interface, which allows you to interact through your web browser and administrate a lot of the different sort of fundamental concepts that are part of Octane. And it's got a full headless API and repository on the back end. If we look at the architecture of this application, I mean, this is a true client server, single page application built natively on Blazor. So you've got, starting at the bottom, you've got your server part of your application, which utilizes .NET Core and Entity Framework. You've got, you know, a repository layer which interacts with the databases. Currently, the application only supports SQL Server or local DB. However, in the next version, there'll be support added for SQLite, MySQL, Postgres, and a variety of, you know, other databases to make the database layer truly cross-platform. It's got a full REST API that you can take advantage of to build applications. It's utilizing the I-hosted service capability in .NET Core to allow you to run or to create background processing jobs that can run on a schedule. And then, of course, if you build custom modules, those APIs can be deployed independently to the back end as well, much like you know, what you would do in a microservice-based architecture approach. On the front end, you can run on either Blazor Server or Blazor WebAssembly as your hosting model. You've got a set of services, which are basically your API wrappers, which internally call HTTP client to access your backend web APIs. You've got your portal UI framework, which allows you to pull your user interface together and all of the rendering of the different modules. And of course, the multi-tenancy capabilities. And with that, I'm going to switch over and actually do a demonstration of Octane, but also talk a little bit about the difference between static applications and dynamic applications. So first of all, I'm going to talk a little bit about a static application and just sort of put it in context for folks. So if you went into Visual Studio and you created a new project and you created a Blazor application. So I've already, you know, walked through the wizard and created an application. And we're going to see that I used the Blazor WebAssembly template. Because if I look at the HTML file, I can see that it's referencing blazor.webassembly.js, which is the sort of the underpinnings of the Blazor WebAssembly. If I was running on Blazor Server, it would say blazor.server here. We've got a set of pages, and these pages are our Razor components. So in our index page, it's just got some very static content. You'll also notice that it supports routing. So when I go to the root node, like sort of the root element, page element, this particular component is going to be rendered. It has a counter component as well. So if I go to the /counter route, this component is going to be rendered, and fetch data is another component as well. And so if I run this application, and we'll see it's going to fire up my browser and loading. And because this is running on WebAssembly, it actually downloaded the assemblies from my server into my web browser, and the application is running natively within my web browser at this point. And I can click through the various pages. And of course, like I mentioned, because of the route mappings, those particular components are going to be rendered on the page. This is a simple counter component, and I can click on it and it increments a counter to show the interactivity, and click on fetch data. And this is actually, you know, rendering some static data related to weather forecasts, but it's rendering it in the user interface. I guess the thing to point out, though, is that, you know, all of the routes in this application are hard coded. So if I wanted to, you know, change my route to use a different name, like maybe weather, I'd have to go in, modify the code, build the code, deploy the code, and then run the application. Similarly, if I wanted to change the content in the home page, you know, even though it's just basic static content, I would have to go and modify the content, do a complete software development lifecycle, right? Build, deploy, in order just to change a minor, make a minor modification to my application. So, I mean, these are the sort of limitations of what a static application has to offer. So what I'm going to do now is I'm going to basically rebuild the static application, which is, you know, based on the Blazor WebAssembly template, and I'm going to build it as a dynamic application. So with that, I'm going to switch over to Octane. So what I have in Visual Studio here is the actual, you know, the latest source code from the Octane repo. If I go to the Octane repo on GitHub, you know, you can, of course, download the code or clone the code. And basically, this is exactly the code that I have running in my local environment. I'm going to point out a few things here. So in the server project, I've opened the app settings.json file. By default, I don't have a connection string, so I don't have a database that's been created yet for my application. It's going to create that database for me automatically. By default, I'm going to run on Blazor server as my runtime hosting model to begin with. And I'm going to show later how you can run on WebAssembly as well. I am specifying a site template here. There's a couple of default site templates that are provided. One site template provides you with a set of sort of default content within your site and a set of default pages. I'm going to use the empty site template because I basically want to build an application from scratch and I don't need any of that default content getting in my way. So I'm going to go ahead and run the application and it's going to do a build. And it's going to present a installation wizard for me. By default, I'm just going to accept the defaults, which is going to install like a local DB database for me using integrated security. I've got to create the initial user account, which I'm going to use to access the application. And I'm just going to use just a bogus email address because it's not important for this demo. When I click install now, it's basically provisioning the database with all of the entities that are needed. And it's going to come up and it's not going to look like much because, like I said, I used the empty application template, which basically has a single homepage with no content on it. We can look in the back end and we can see there's a control panel, which gives me some advanced functionality. And I can go into the admin dashboard as well. And I can see that there's a lot of different capabilities that are here and that I could take advantage of to manage this particular application in a more interactive way. So with that, the first thing I want to show you is that you can change the look and feel very easily with Octane. And so I'm going to switch back to Visual Studio for a moment. There's a notion of themes, and there's a couple of default themes that are built into Octane. There's a default theme, which is called the Octane theme, and there's a Blazor theme. So I'm going to look at the Blazor theme for a moment. The Blazor theme emulates the same look and feel as what you would get if you created an application using the Blazor template, which is what we just looked at earlier. So if I look at this sort of, and basically the themes in Octane utilize Razor components. Everything is a Razor component when it comes to the user interface. So if I take a look at this Razor component, so default.razor, I can see that it's basically just HTML markup, and it's using a variety of different other Razor components to render specific aspects of the page. So there's a breadcrumb menu, there's a logo that it can render, there's a vertical menu, there's some links for the user profile, login, ways to access the control panel, and areas where content is going to be rendered. This is essentially all you need to create when it comes to building a theme for Octane. It also is going to link in a number of resources. So in a framework like Octane, you could still take advantage of other frameworks, and we want to take advantage of Bootstrap for CSS aspects. I'm going to have some jQuery capability. Yeah, so basically this is the way that we can pull in resources into our application. And we do it this way, we build it into our theme because we don't want to be modifying the Octane framework itself. Like that's the whole fundamental aspect of a modular application framework, is that you don't modify the framework itself, you treat it like a black box. And then if you treat it in that manner, you can upgrade it to newer versions very easily. You build all of your extensions externally to the web application framework. And I'm going to show you that in a moment. So if I go back to my application, I'm going to go into my site settings. And I have a whole lot of options that are available to me in my site settings, but I'm going to focus in on the theme. So I'm going to change the theme to the Blazor theme. And I'm going to specify a container as well. These are both aspects of the theme. And I'm going to go ahead and I'm going to save that. I saved it. It says the site settings are changed. I'm going to go back to my home page and bam, it completely changed the look and feel of my application. And it looks a lot like the Blazor template now. Okay, and with that, I'm going to add a couple of pages. Well, actually, I'm going to go to the home page. And what we need to do is we need to add the content that was on the home page from the Blazor template to this home page. So to do that, I'm going to go into my control panel. There is a module that's been built in to Octane to manage HTML text. It's the only built-in module that is provided. And I'm going to name this hello, world so that it matches the other application. And so it added it to the page. And so this is an instance of that particular module that is running on the page. I can add another instance of that module to this page if I want, or I could add it to other pages. So you've got that flexibility, that versatility that I was talking about with a dynamic application. We're going to add some content to this module now. So I go into sort of my edit mode, and I can edit the content now. And I'm going to use the raw HTML editor, and I actually have that content here so that I don't have to remember all of it. And I'm going to save it. And if I go out of edit mode, we now have a home page which has the same exact content on it that the Blazor template had before, which is pretty cool. So now I'm going to add some additional capabilities to this site to make it emulate what the Blazor template provided. So in order to do that, I need to add a couple more pages. In order to do that with a normal static application, I would actually have to go in, create a Razor component, modify the code, build, deploy it. With a web application framework like Octane, I can go in and I can say I want to add a page. So this is going to all happen very dynamically. So I'm going to create a counter page. And down in the appearance area, I can add an icon so it really matches. So I'm going to use, by default, we ship open iconic. So I'm going to use the this icon, and in my permissions area, I'm going to say that all users can see this page. So now I have a counter. I'm going to create a fetch data page as well, because that was obviously another page that was in the other site, and I want to create list as rich. And go into permissions. I'm going to open this one up to all users as well. So now I've got a fetch data page. Nice. Okay. Now, of course, Octane doesn't provide, default components which match the functionality of the Blazor template, right? So you actually have to build those. So I'm going to show you now how those are built. So going back to Visual Studio, I have another version of Visual Studio open here where I've created a completely separate project. It's actually a completely separate solution, which contains some Razor components in it, and it's going to be built into its own DLL. If we look at the index.razor page, which is part of it, so this is an Octane module. So I've taken basically the Razor component that was part of the Blazor template, and I've duplicated it here. So it's basically the counter control, which allows you to click on the button and it increments the counter. If I build this, it's going to just build this into its own distinct assembly. And it's actually, because I have this package project contains some command files which sort of post-build events, which will copy DLLs for me automatically. It's copying them to the Octane instance so that they're immediately available. If I switch over now to the weather forecast, I've also built a weather forecast module as well. The weather forecast module is a little bit more elaborate. It has an index page, which renders a table based on data that it retrieves from the back end. How that data is retrieved is it's actually using the HTTP client functionality and calling, it's accessing a resource that's on the server, which is a resource called weather.json, which is your data. If we look in the back end, we have a server project as well. And we look at weather.json, and it contains all of that same weather information. And there's also a shared project where we have a model, which is going to be shared between the server project and the client project. So basically, when I compile this, it's going to create 3 different DLLs, right? It's going to create a client DLL, a server, and a shared DLL for my weather project. And then it's going to also automatically deploy those to my Octane instance. So if I build this, we can see that it's creating the DLLs and it deployed them. So now if I go back to my Octane instance and I run it, it's going to recognize that there were a couple of new modules that were created, and it's going to automatically make them available in my environment. So if I go to my counter page, I want to add an instance of that counter module we just created onto this page. So I can go and I can look at my common modules and I can see, hey, there's my counter module. And I'll just call it counter, and I'll add it to the page. All right, so if I click that, fully functional counter module that's been packaged up and deployed as its own distinct DLL. And it's being composited into my overall application at runtime. So I'm sure a lot of folks have heard about the concept of micro front ends. This is very, very similar to a micro front end in the sense that it's taking a lot of different user interface components that are actually compiled into their own separate DLLs and rendering them all together into one consistent user interface at runtime. If I go to my fetch data page, I can add my weather module that I had created. We'll just call it weather. I'll add that to the page, and it is fully functional, rendering the data that is available on the server. So what I've done there is built a couple of custom modules, deployed them into Octane, and made them immediately available in a dynamic way. So the template application that's provided as part of Blazor is pretty basic in its functionality, right? These aren't really what I would consider real world applications, right? There's actually no data access that's happening. Fetch data, makes a call to the backend server, but it's all static data. This is not like any type of real business application would not work this way, right? You would need to be building something more elaborate. So I'm going to show you how to do that very simply in Octane. So what I'm going to do is I'm going to go ahead and I'm going to create a new page. We're going to call this conference. So we're going to create a conference module. I'm going to maybe add an icon to this. I'll just say, maybe I'll use the globe, and I'll say that this is available to everyone to see. So I have a conference page that I've created. Now I want to create a module. How do I do that? So Octane has the ability to sort of speed up the effort of creating a new module by creating some scaffolded code for you. So what I do is I go into my control panel, I choose developer modules, and I have a module creator, which I can add to my page. And I'm going to call this sessions, and I'm going to add this module creator to my page. The module creator is basically just a way to scaffold a set of code. So I'm going to just call this code camp. I'll call it session. And I'm going to use an external template, meaning the code that is created is going to be external to my Octane instance and created, outside. I have a framework reference to 2.0.1 of Octane, which is the version I'm running. And it tells me where it's going to create this code for me. So I click create module. It tells me that the source code has been created at the location specified. And of course, in order to utilize this module, I'm going to need to compile it and deploy it and then restart my application. So with that, I'm going to close that application, and I'm going to go to my file system, and I'm going to see that, oh, there's my codecamp.session code that was created. It's got a client project, package project, server project, and shared project, and it scaffolded out all of this code for me and used like tokenization to replace the values so that it was, customized to my needs. So I'm going to open the solution file for that. And we'll see that we've got these 4 projects. The client project contains, all of the Razor components. So I've got an index component, which is going to be my main view. It's going to show a list of my conference sessions. I've got an edit component, which is going to allow me to add or edit sessions that I create. I've got a settings component, which is not really going to be taken advantage of in this particular instance. I have services that were created as well. So basically services which wrap utilize HTTP client to call my back end APIs, but it scaffolded out all this code for me. In my server project, I've got my controller, which it created. I've got a repository, which it created as well. I've got database scripts, which it created. So, it created a lot of code. And of course, in my shared project, it's got my model as well. So if I go ahead and I build this, it's going to build these 3 different projects, and it's going to deploy the DLLs and the PDBs to my Octane instance automatically. And it's also going to deploy a couple of additional files. Modules can have their own distinct CSS, their own distinct JavaScript, So it's going to deploy those as well so that those are accessible in the runtime environment as well. And so now I should have a functional module. So if I go back to my Octane instance and I run it, again, it's going to recognize that that new module was created. I'm going to go to my conference page and it says, once you've compiled the module and restarted the application, you can activate. So I'm going to say it's activated. All right. And the module has been activated. There is some information, it's like some documentation, which was included in the default index page for my module, which I didn't remove. I could have removed that, but it just tells me, where all the different files that were created in the scaffolding exercise. So if I want to add a session, click Add Session, and I can say, the session that I am doing right now is called Trailblazor. And so it created it, and it created this in the database. So it created a database table called session, and it actually, allowed me to create a particular entry in the database. I can go in and I can edit additional content, save it, I can delete, and all of this functionality was just scaffolded for me. So very powerful, and allows me to deploy, a completely new functionality to my Octane environment simply by creating an external module. Last thing I want to show you is there's also the ability to take advantage of pre-built modules. So if I go into my browser here, I can go and I can see in NuGet, someone has created an Octane.blogs module, which is a module for blogging that I might want to take advantage of. I don't want to, maybe someone's built this and it's perfectly good for my needs, and I don't want to build it myself. So what I can do is I can go back to my running Octane instance, and I can go into my admin dashboard and go into my module management area. These are the list of modules which are already available in my environment. I want to install a new module. And I can see that it basically went out to NuGet and it sees that there's a blogs module on NuGet that's available for my version. So I can download that. So it's downloading the module, which is basically a NuGet package from nuget.org. Downloaded it successfully. Now I'm going to install it by clicking the install button. Now that it's installed, I have to restart my application in order for that new blog module to be available. So we'll go back to Octane and we'll run the application. It will recognize that there's a new blog module that was been installed. And I'll just put it on the conference page for simplicity. So if I go into my control panel, I'm going to see that if in the common modules, there's a blog module. Let's call it blog. And I'll add it to my page, and we can't see it because it's down below the fold here. So if I go and I can actually move content up. So I'll move the blog module to the top of the page. I can add a blog. So title, blog entry, save it. And so it basically installed a pre-existing application, essentially, including the full database support for it. And it installed it into my Octane instance and made it immediately available so that I could take advantage of it. I think that kind of covers the gamut of the different dynamic capabilities that are part of Octane. The only other thing I wanted to show you is that if you want to run Octane on WebAssembly, you basically can just change the runtime and specify WebAssembly. Rerun we'll do a rebuild on the application, although it's not even necessary, because it'll run the same assemblies regardless. So, and now I can run, come on. And if I run it, Octane again, it will be running, rather than running on Blazor server, it will be running on Blazor WebAssembly. And of course it is. And actually all of those modules which we created previously are also running on WebAssembly. So the counter module, fully functional, running on WebAssembly, fetch data running on WebAssembly, the conference module, which includes both session module and blog module, all running on WebAssembly now. It's because these modules were built in a client server manner. They run equally well on both Blazor server and WebAssembly. So very powerful capability. And so with that, I'm going to go back to my slides, and I see that I'm running short on time. But we can talk a little bit about some of the considerations when it comes to building static or dynamic applications. So talk a little bit about static linking, assembly loading, application startup. So these are some of the more technical complications that you need to be aware of when you're building a dynamic application. Octane takes takes care of a lot of these complications for you and allows you to focus on building your modular applications and by providing a lot of the underpinnings for you. But these are all things that you need to be aware of. So static linking. Microsoft tooling relies heavily on static linking for all types of development and deployment activities. There's a lot of magic that most developers aren't even aware of related to package management, dependency management. And those are things that you sort of have taken for granted over the years because Visual Studio is doing a lot of magic for you. When you're building a dynamic application, there isn't any static linking, right? That you're not tightly coupling your modules that you build to the host application. And because of that, you need to have a better understanding for how the various aspects of .NET Framework and .NET Core work, and you need to take responsibility for those. So most of the challenges which I'm going to describe in subsequent slides are related to having to find alternatives to static linking behaviors. Because the static linking model is the model that Microsoft provides by default, and it's the model that Microsoft focuses on in its tooling by default, but it doesn't help you if you're building dynamic applications. For example, when it comes to assembly loading, .NET Core automatically loads only those assemblies that are statically linked to your main application. So again, this is so you have to have your assemblies sort of tightly coupled to your main applications in order for them to be loaded by default. In a dynamic application, there'll be a whole lot of assemblies that are in the bin that are not going to be loaded by default because they're not statically linked. So you have to come up with a method for loading those assemblies dynamically yourself. And there, of course, Microsoft does provide the capabilities to do that. And so, of course, Octane uses the assembly load context to load assemblies from the bin and loads them into the app domain so that they can be used. But I mean, again, this is something that the framework has to do manually because .NET Core does not do this automatically. Assembly loading on the client. So when you're running in WebAssembly, again, when you're running on WebAssembly, it's relying on static linking to figure out which assemblies need to be downloaded to the browser. Well, in a dynamic application, again, that's not going to work. So the dynamic application framework needs to figure out which assemblies need to be downloaded to the browser and take, do that manually, and then load them into the app domain as well. There is methods, again, that are provided by Microsoft to do this. It's the same methods that they use internally for getting Blazor WebAssembly up and running, but I mean, you have to take advantage of those as well if you need to load additional assemblies into the browser. Octane takes advantage of this as well. Application startup. So if you need an application that is extensible, so that people don't have to modify the sort of the host application, you need to provide extensibility points that they could take advantage of. One of the sort of bottlenecks in most .NET Core applications is application startup. And so you need to make application startup more extensible so that third-party logic can be plugged in and executed at runtime. And so what we've done in Octane is basically emulate the .NET Core startup services so that there's an interface that a module can implement, and it can implement a couple of methods, and those will be executed during the startup phase. So basically, we have an iServer startup. You'll see that the methods that it allows you to implement are exactly the same as the methods that are available in the regular .NET Core startup, but this allows extensibility. So modules can inject additional functionality. Service registration. So dependency injection is another sort of big challenge when it comes to dynamic applications, because if you deploy these applications, you're not going to, you need to be able to register these services in startup. And there's, I mean, a variety of different ways that you can do that. The way that Octane's chosen to do that is we basically introduced an iService interface, which a service can implement. It actually has no method, it's just a stub interface, but if you implement it, then the framework will be able to discover it during startup, and it'll do an auto registration of the interface. Of course, there's other components out there that do similar things, but this is just the method that Octane uses. Routing. The default Blazor application provides you with a default router, which is sort of a page-based routing capability. That's not what we needed in order to create an application framework like Octane. We needed it to be more dynamic, and we needed the router to be aware of configuration, which is specified in the database, and then utilize that configuration at runtime to render, a particular rendering for a virtual kind of a page concept. So basically, you can unplug the default router that's part of Blazor, and you can build your own. In fact, a router in Blazor is just a Razor component. If you look at the default router that's provided as part of Blazor, it seems quite complicated on the surface, but when you boil it down to the basic elements, it is just a Razor component. So Octane basically has its own site router, which is just a Razor component, and it takes advantage of this ability to interact with the database to render a page in a dynamic way. Razor component rendering. So typically, when you are developing a static Razor application, you would include all of your Razor components within the same monolithic application, and then it's really easy to reference them because you just use the tag name of the component in your page rendering. That is, again, very tightly coupled, very static in nature. That's not the way you would do things in a dynamic application. You need to be able to dynamically load, like instantiate a component based on its type name, and then inject it into the page. And there are primitives which Blazor provides that are available. They're just not well, I guess, documented or extensively used, but this is exactly the approach that Octane uses to do Razor component rendering. So if you want to do dynamic rendering of Razor components, it's actually pretty simple. You basically just load the type based on the type name, and then you use these primitives, which is like the builder.open component, builder.close component, which will render that particular component output to the page. Hosting models. We talked a little bit about the fact that Octane supports Blazor Server and Blazor WebAssembly. In order to allow an application to run on both hosting models, you need to build your application in a client-server manner. So you can't take advantage of things like direct database calls from your Razor components. That is possible if you're creating a static Blazor application and you intend to only run on Blazor Server. You can actually interact with the file system from your Razor components. You can interact with the database directly. However, if you then try to run those components on Blazor WebAssembly, of course that won't work because the application is running from the browser, and the browser doesn't have access to those server-based resources. So that's why I'm saying you have to build things in a client-server model and pay attention to where the workloads are executed. In order to switch between the different runtimes, it's actually pretty simple. Basically, it's a difference between loading the WebAssembly script file versus the Blazor Server script file. So pretty straightforward there. Deployment, it gets a little bit tricky when it comes to dynamic applications, in the sense that Visual Studio does a lot of magic behind the scenes when you choose to do a web deployment from Visual Studio. I mean, it figures out all of the different NuGet packages that you have reference to, and it basically pulls the DLLs from those NuGet packages into your deployment folder for you, and it figures out all the different dependencies. If you're building a dynamic application, you have to take responsibility for a lot of that. And so because of the sort of loosely coupled nature and the benefits you get, you still, there are some downsides, and that means that you have to take responsibility for understanding your full deployment story. And so you have to figure out where all of the different bits that you're developing need to be deployed. The Octane community is, primarily on GitHub. I showed you the GitHub repo. Current version is 2.0.1. Next version is 2.1, and that's the version that's going to have support for cross-platform database support. And that is also going to enable EF Core migrations for modules. It's already possible to do that, but there's no good examples. So there'll be some good examples of that. And the end goal of this is that basically if somebody builds a third, like an external module for Octane, it should be capable of running on any database platform that is supported by the Octane framework itself, without the developer doing a lot of the heavy lifting themselves. That is the end goal. That release is expected to come in April 2021. And that concludes my presentation. So if there are any questions, I know I ran a little long.
Not a problem.
Not a problem. It was really cool. So I liked also the first part, that and the hands-on and the demos, but also this last part where you took different aspects and said, okay, this is the things that we need to consider and how we should approach them. But I think, yeah, maybe we take one question, and that would be, with all this, what do you think it's still missing for Octane, or better said, what is the roadmap for the coming period?
Yeah, so the next version would be focused on the database aspects, so running on multiple databases. The version beyond that would be focused on enabling multiple authentication schemes. Right now, it uses the .NET Core identity system, but it only has sort of local authentication, meaning you're authenticating against that local user store and using, basic cookie-based authentication. There's a lot of folks that would like to use Azure B2C or, OpenID or, various other authentication schemes. And so that would be, a fairly substantial piece of work to allow a framework to, make it pluggable so that you could plug in various other authentication schemes.
So for the people in audience who enjoyed the talk and Octane, should we launch a call for contributions or?
Absolutely, yeah. If people would like to participate in the open source project, we always like to have contributions. We've had some really amazing contributions over the last 2 years. I think the most recent one that I'd like to mention would be somebody actually implemented localization support. So the ability to localize the user interface into other languages. I mean, that's a pretty substantial undertaking, and we have a community member who stepped forward to implement all of that. And so there actually is quite a large community that's already formed. I think there's probably 30 or 40 folks that have made contributions to Octane over the last 2 years, at various levels, which is pretty amazing.
Mm-hmm. And do you manage to also get contributions from your internal community at Cognizant? That would be an interesting.
Yeah, there's a couple folks that are following along. There hasn't been as many actually from internal. It's been mostly external contributions at this point.
You have to create like a dedicated guild, right? For
yes, an open source guild. Correct. Yeah, that would be great.
Exactly. Okay.
All right, Shaun. Well, thanks a lot for being with us.
Let's not forget the promise that we'll be here in Yash when possible next time.
Yes, I would love to see Yash.
Looking forward to that.
All right.
Thanks a lot.
Have a
Thank
great
you
day.
very much.